All right, lesson 11-4, the quadratic formula. This is the big one. Okay, so our question is, what do you need to do to get your quadratic formula answers into simplest radical form? If you watch the lesson 11-4 bonus video, then you've seen that we came up with a way that we came up with a formula that we can plug any of our quadratic formula or our quadratic equations into to use in our formula. So if you have something in standard form, where it's ax squared plus bx plus c, so it has to be in standard form, then the a, b, and c are the numbers. The a is the coefficient of the x squared, the b is the coefficient of the x, and the c is the constant over there. So if you've got those three numbers, then we found out in that last lesson that you can just plug them in here. So whatever the b value is, you plug it into these two spots. Whatever the a value is, you plug into these two spots. Whatever the c value is, you plug it in that spot. And then you have your answer. Okay, so you're going to need to memorize memorize this formula right here. And the formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's a lot to remember. So you know what? I think we're going to need a song. I'm really depressed because you guys aren't here to sing it with me. So those of you watching at home, I need you to sing along. There's a song. It was really popular in the 60s. It was on the radio and everything. So back in the 60s, they sang this all the time. Everybody knew the quadratic formula because it was on the radio. Anyways, the song, the words of the song are the quadratic formula. X equals negative b plus or minus the square root b squared minus 4ac all over 2a. People loved it in the 60s. I think you're going to love it too. So here's the song. Let me get the note right. Maybe start with a G. Okay, that sounds good. All right, here we go. Here's the song. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Isn't that beautiful? It's beautiful. All right, so you're going to need to sing so you can memorize this. You got to memorize it, so you need to sing. So I want to hear you singing at home. Okay, here's the song again. Sing it with me. X equals negative b plus or minus square root b squared minus 4ac all over 2a. It's pretty. All right, now just the guys. We'll go deep. Here we go. X equals negative b plus or minus square root b squared minus 4ac all over 2a. That was pretty strong. Pretty strong. And now just the girls. Just the girls singing. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Oh, girls, that was beautiful. That was so good. So good. Okay, so when we all finally get back to school, we're singing this. It's got to be done. My year is not complete until I see you sing this. Maybe we'll go around to like all the hallways. We'll be like, hey, we're going to sing it for you. We'll just like go up and down the hallways. It'll be great. Trust me. Anyways, we're going to use this in a second. Before we get to that, we need to figure out how we're going to simplify the answers that we're going to get here. So when we simplify our answers, we're going to end up getting answers that look like this after we've used the quadratic formula. So like something like negative 16 plus or minus the square root of 98 over 8. Okay, so there's a couple things that we want to look for when we are simplifying it. Number one, we want to look at the radical and ask ourselves, can that radical be reduced? And indeed, this one can be reduced. We know that 98 should be 2 times 49. 49 is 7 times 7. So just like Friday night, couples go out, singles stay home. So we can change this into -6 plus or minus 7, because couples go out, root 2 over 8. Now, can we reduce the 16 and the 8? The answer is no. The 8 is over or is under both the 16 and the 7. It's connected to both. So the only way to reduce one of these three numbers is to reduce all of them at the same time. So even though 16 and 8 reduce, 8 and 17 and 7 doesn't reduce. So therefore, we cannot reduce any of them. If all three of these can reduce by the same number, then we will reduce them, like on this next problem. Here's example 2. Example 2, we've got -10 plus or minus the square root of 8 all over 4. All right, so we're going to do the same thing that we did last time. We're going to reduce the square root of 8. This is 2 times 4, and that's 2 times 2. Friday night, couples get to go out, singles have to stay home. Am I right? Am I right? And we get -10 plus or minus 2 goes outside, 2 stays inside, so 2 root 2 over 4. Now on the previous one, 16 and 8 couldn't reduce because all three of these didn't reduce. Now on this one, the 10, the 4, and the 2 can all be reduced, so we must reduce them. So the 2 goes into all these, so I can turn that into a 5, this into a 1, and this into a 2. So my final answer is going to be -5 plus or minus, I don't need to write 1 root 2, I could if I wanted to, but I'm just going to write root 2. So this is 1 root 2, and then all over 2. And that would be my final answer when I simplify it. So we need to look for a couple things. Number one, can you reduce the radicals? And number two, can all three of these numbers reduce? Those are the two things you want to look for when you are taking your quadratic formula answers and putting them into simplest form. Okay, now let's actually, from the beginning, solve using the quadratic formula. All right, here we go. Let's start with example 3. All right, so we've got 5x squared minus x minus 7 equals 0. All right, the first thing that we want to do is we want to identify our a, b, and c values. So the a value is the number in front of the x squared, that's 5. The b value is the coefficient of the x to the first term, so this is -1. If there's no number there, it's a 1. So we do b is -1, and the c value is -7. So c is -7. All right, we've got our a, we've got our b, we've got our c. The next thing that we're going to do is plug these into the quadratic formula. Remember the quadratic formula? Of course you do, because you know the song now. It's x equals -b plus or minus square root b squared minus 4ac all over 2a. That beautiful song right there. So what we're going to do is we're going to start plugging everything in. So b, I do negative. And then instead of b, I plug in -1. You have to really watch that. Stop, you stupid bell! There's nobody here! Thank you. So we get -1 plus or minus the square root. Plug everything in parentheses because a lot of people will miss this negative because this -1 is making it positive. So we'll plug in b squared. So b, I'm plugging in -1 squared minus 4. And then instead of a, we plug in 5. Instead of c, we plug in -7. And then it's all over 2a, and a was 5. All right, there's a lot of stuff to clean up at this point. I would suggest that you clean up in steps, and I make a couple passes through this. My first pass is going to clean up this section here, this section here, this section here, and this section here. So I clean up this, these 3 things being multiplied, and then these 2 things. So that's my first pass as I go through simplifying this. So the first thing is the -1. That means that's going to be +1. Plus or minus square root. So I now look at this part, -1 squared. That's always going to be positive because we're squaring. So -1 times -1 is +1. Watch your negatives on here. I've got 2 negatives here. 2 negatives means that it's going to be positive. So -4 times 5 is -20. -20 times -7 would be positive 140. I think, yeah, positive 140. And then 2 times 5 would be 10. So that's my first pass. You don't want to try to do too much at once. Just do one pass through there. You can see there's still stuff that needs to be reduced. At this point, I think that this inside here would be nice for a second pass to clean up. Don't try to do too much at once. Be patient. All right, and so now we're looking at something that looks like these 2 problems here. So we need to ask ourselves, can we reduce any of this? Well, 141, let's see, 1 plus 4 plus 1 is 6, so 3 has to go into that. So let's see, 3, and then 3 goes into there 47 times. 47, 11, I think that's prime. So there's no pairs in there. So that's our final answer. We can't reduce a radical, and there's nothing else to reduce. That is the answer. Now there's 2 actual answers there. You got to remember that. The 2 actual answers, and you don't have to write this down like when you're doing your homework, but realize what we're doing here is we have 2 answers. One of the answers is 1 plus the square root of 141 over 10. The other answer is 1 minus the square root of 141 over 10. So there's 2 answers there. These are called our roots. These are called our solutions. These are called our x-intercepts. These are called the zeros of the function. So all these things are the same thing we've been doing before. We're just finding the x-intercepts or the solutions. We call them zeros. We call them roots. Okay, so there's a whole bunch of different names for the same exact thing. Here's our 2 answers. Now, the square root of 141 is close to 12. So this looks like 1 plus almost 12 divided by 10. So that's like almost 13 divided by 10. This is 1 minus almost 12 divided by 10. So this is like almost -11 over 10. So those are the 2 numbers that we found there. All right, a couple more. We're just going to practice this 2 more times. After I've written down a problem, if you want to try it out yourself, you can just hit pause and then see if you got the correct answer. I will be going faster through these next 2 examples. Example number 4. Example number 4, our next problem will be solving x squared plus 6x equals 27. All right, you notice that this one is not in standard form, so you cannot use the quadratic formula until it's in standard form. So give it a shot, push pause, put it in standard form, and then use the quadratic formula, and then we'll see what we got. All right, press pause. Okay, get off your phones, press pause, try it out yourself. Don't just wait for me to do it for you. Try it out yourselves. All right, so I'm assuming that you press pause because you're good kids. So we're going to subtract 27 from both sides. We get x squared plus 6x minus 27 equals 0. All right, so we're going to use the quadratic formula for this one. So the quadratic formula is x equals negative b. So on this one, a is 1, b is 6, c is negative 27. So x equals negative 6 plus or minus square root 6 squared minus 4 times 1 times negative 27 all over 2 times 1. All right, so I've plugged in all my numbers. I'm going to clean up my 4 spots. So here I'm going to make this into negative 6 plus or minus. The next spot I'm going to clean up is 6 squared, which is 36. Next thing that I'm going to clean up is negative 4 times 1 times negative 27. I know that answer is going to be positive. Stupid. Oh, I hate that. Let's see, 2 times 27 is 54. 54 times 2 is 108. Really watch this part right here. This is where you're going to mess up if you do mess up. It's either going to be here or here. All right, then it's going to be all over 2. Okay, I'm going to keep on cleaning. This 36 plus 108 makes 144. So this is negative 6 plus or minus the square root of 144 all over 2. All right, so I got my answer. I can reduce the 144. That's a perfect square. That's the perfect square of 12. So I get negative 6 plus or minus 12 over 2. Now, since I have actual answers, I'm going to write those two answers down. Negative 6 plus 12 is 6 over 2. The other answer is negative 6 minus 12, which is negative 18 over 2. And both those answers reduce to 3 and negative 9. Those are my two x-intercepts, 3 and negative 9. And if you noticed over here, you could have factored this one. What multiplies to give you negative 27 but adds to give you 6? Positive 9 and negative 3. So x plus 9 and x minus 3, set those equal to 0. Remember from the last unit? You could have factored this one and not gone through all this work. So some of our other methods that we've already done are faster than the quadratic formula. The quadratic formula works every single time. But we've got this big old toolbox of these 4 different formulas that or 4 different ways that we found out we can solve quadratics. We can solve by, taking the square root of both sides, by factoring and using the principle of zero products, by the, what's the method called? The completing the square method. And now we've got the quadratic formula. So we've got 4 different methods that we can solve. The quadratic formula and completing the square always work, but they're not always the most efficacious way to do it. This one, it probably would have been more efficacious to just go ahead and factor and then set your factors equal to 0. You wouldn't have had to do this much work. But if you didn't notice that, the quadratic formula works every single time. All right, one last problem. And then you're good to go. Example 5. You're going to do x squared plus 8x minus 16 equals 0. All right, pause it. Actually try to do some work yourself. Pause it, try it out yourself, and then unpause to see if you got it right. All right, my A value is 1, B value is 8, C value is negative 16. All right, so I'm going to do x equals negative 8 plus or minus square root 8 squared minus 4 times 1 times negative 16 all over 2 times 1. All right, I'm going to clean up the 4 spaces. I'm going to clean up here and get negative 8 plus or minus. I'm going to clean up here and get 8 squared, which is 64. I'm going to clean up here. I'm noticing 2 negatives, so that's going to be a positive. And then 4 times 16 should be 64. And then it's all going to be over 2, which is the last place I clean. Now, over here, I can take this square root part and combine those two and get 128 over 2. All right, now I need to take the square root of 128 and reduce it. So 128, if I break that down, that can be 2 times 64. And 64 is 8 times 8. So I have a pair of 8s and a 2 left over. So x is going to be equal to negative 8 plus or minus, and then the square root of 128 reduces to 8 root 2. 8 root 2 all over 2. So I see that all 3 of these numbers reduce. So 2 goes into 2 once, 2 goes into 8 4, and 2 goes into 8 4 times there. My final answer is negative 4 plus or minus 4 root 2. And I don't need to worry about it being over 1. It's always over 1. That is it. It's beautiful. All right, that's all I got for you. Bye-bye.